Okay. Lee, I'm going to make just really a very brief intro, and then it's going to be you.
Thank you.
Hi, everyone. My name is Kareem Bugida. I'm the Dean of Libraries at University of Rhode Island. This is Rhode Island AI Meetups. We've been doing this for a few years now. This is event number 24, I believe. Our goal is really to democratize AI and related technologies. And it's not just about the technologies, it's also about social impact and ethics. Today we have Yuan. Lee is with us within University of Rhode Island Libraries and exactly DataSpark. DataSpark is a data analytics unit. He's a senior programmer analyst since 2018. He's also a URI alum in computer science. And we've been using machine learning for a while now within DataSpark. And this talk is really responding to your demands. So we get many requests to do introduction to machine learning. So we're listening to you. In terms of logistics, Lee is going to make talk for probably 30 to 40 minutes. And then we're going to do Q&A, but please use the chat. So don't wait until you're done. And then when Lee is done with his talk, so we're going to go through the chat. Okay. So Lee, please go ahead.
Okay, thank you so much for introduction. And welcome to Machine Learning 101. My name is Yuan, Senior Programmer at DataSpark. And so let's start the presentation. If you don't have any programming experience or computer science background, it's totally fine. So this is level 101 level class. So please be relaxed and enjoy machine learning. Machine learning is a very hot topic recently. However, the term machine learning was coined by author Samuel in 1959. That is about 60 years ago. So machine learning, like a wrench or a screwdriver, so it is kind of only a tool that helps people rather than confusing people. So before talking about machine learning, let's try to answer some simple questions. First one, how to calculate the volume of a sphere? I think that is quite easy. And most of you here maybe still remember the equation. That is easy, right? Okay, the second one. How to calculate the distance of a linear motion with constant acceleration? That seems a little bit complicated, but we still have an equation available here, thanks for scientists in the past. So just like I said, they are quite easy questions. Okay, next. Can you predict the trend of tomorrow's stock market? It's hard for me. If you are able to do so, you'll be enjoying the sunshine or the palm tree somewhere else, I think. Okay, next. Can you categorize the trees outside your windows? I'm not a botanist, so maybe you are. The last one. Can you tell how to win a chess competition? I can beat my 9-year-old daughter, but no one else. Maybe you could. So what's the difference between these questions? Here, why the first two questions are easy to be answered, but not for the rest? So what's the difference among these questions? The first two questions can be solved by specific equations or rules, but the rest of them cannot be. The only way to solve them is to asking help from the scientists or professionals. Maybe they can help us to find a solution which is based on their experience or their own judgments. But still, they cannot guarantee the outcome is correct all the time. So generally, machine learning is kind of a tool that solves such kind of questions like a professional. Here's a definition from Wikipedia. Machine learning is a study of computer algorithm that can improve automatically through experience and by the use of data. So here we have 3 key points. One is learning from data. Yeah, data is very powerful now. Data is everything. So try to connect data as much as you can before learning. And second is experience, not rules. Learning from experience, not rules or equations. Because that might be a kind of the rules behind the data, but we still cannot specific by words right now. Third, the solution. The target of machine learning is to find the best approach of the problem. The general algorithm is keeping learning to optimize the outcome until a threshold reached. So there are 3 types of learning approach here. They call supervised learning, unsupervised learning, and reinforcement learning. We will discuss them one by one. So the first one is supervised learning. The definition is the computer is presented with example inputs and their desired outputs given by a teacher. And the goal is to learn a general rule that maps inputs and outputs. A very traditional example is predict the trend of stock markets. Also, we can predict the weather for tomorrow. That is also a kind of example for the supervised learning. So the data we're feeding the algorithm has 2 parts. One part we call its feature. That is kind of general data, such as the temperature, the seasons, the air pressure, and humidity. The other part we call label, also known as the results. Like, yes, it will rain tomorrow. No, it will not going to rain. So the purpose of supervised learning is to try to learn the pattern from the previous data and predict the results from the future data. If it sounds very complicated, don't worry, we have an example from my current work. So here's some data. I can tell you some story behind the data. As a DataSpark, we connect the data from some state agencies, like the Rhode, called Rhode Island Department of Education, and DOH, Department of Health. And most of the data we have contain the PII. The PII means personal identifiable information, which contains the last name, first name, date of birth, SSN, and student ID. To protect the PII, we need to assign a unique ID for each of the person before processing the data in the future. So if a student is a new person, we will assign a new unique person ID for him or her. Otherwise, if the student is already in our database, we need to find out the person ID and assign it to him or her. So here is a question: how to determine the person is already exists or not? So here's our approach. We generate a matrix for each pair of rows, calculate the distance between each field, like this. You know, we have 2 persons, the last name also Smith, and first name, one called Dave, one called David. And date of birth is only 1 day difference. And they share the same SSN and the same student ID. So can I say they belong to the same person or not? Because only they have a different first name. It's hard to say. So we have more experience here, more example here. As you can see, there are some difference between the last name or first name, or DOB or SSN, or the distance of the student ID. So let's take a look for the first one. So the first one, they have the difference of last name is 1, like something, they only have 1 character difference between the 2 last names, and they have the same first name, same date of birth, same SSN, and the same student ID. So can we say they are the same person or not? Maybe it's only a typo according to our experience. So that's probably a same person. So for the first one, we can say that only difference is DOB, date of birth. So that may be also a kind of the typo from the data entry. So probably they also belong to the same person. So for the third one, they have different last name, they have different SSN and different person ID. So probably they are really different people. We should split them into 2 different persons and assign a unique ID for each of them. And the fourth one is quite similar. They have the totally different date of birth, SSN, and student ID. They only share the same name. Maybe the names are very popular here, like John Smith or Dave Smith, something like that. The fifth one, they are very close. They share the same last name, but different first name. The same DOB, date of birth, but different SSN, and only 1 difference between their student ID. Can you imagine what's the situation here? Yes, according to our experience, these 2 persons, maybe they are twins. So they have the same last name, but different first name, the same date of birth, and a little bit difference of SSN, and a little bit difference of the student ID. Okay, the sixth one. They only have the different student ID. The rest of the information are exactly the same. So we believe that might become, maybe they belong to the same person. Maybe this person have registered in a school for twice. So the student have 2 different student ID by accident. But the rest of information are exactly the same. So how about the last one? They have different last name, the same first name, the same date of birth, same SSN, same student ID. Are they belong to the same person? Probably this person is a female and she changed her last name after marriage. So that is our experience. Supervised learning is try to learn the rules from the data and experience. And this experience is coming from the professional or scientific experience and predict the results like a professional. So this is data that we used to make a decision, and we feeding this data to the machine learning, and the machine learning algorithm will learn the experience from us. So in the future, the machine learning can predict the results as ours did. So this is called supervised learning. Okay. So for the unsupervised learning, it's a little bit different. The unsupervised machine learning is learning only from data, not experience. Let's take a look. So for this unsupervised learning, there's no label given to the learning algorithm, leaving it on its own and to find out the structure of its inputs. Unsupervised learning can be a goal in itself. Example, to categorize the species of iris. So the purpose of unsupervised machine learning is not predict, but to find out the pattern and clustering the data. So it will provide another different point of view of the data, but it's based on how you build the data. It's a little bit tricky. We can take a look at this iris categorized problem. So here's the raw data that we connect for the iris. The first 4 columns are the features of the data. They are called some information about the spiral and the petal size, like the length and width. And the last column is a label, which are assigned by the botanist. It will not used for the, it's only used for the display, not for learning. So don't worry about that. And here is the raw data that we are feeding to the algorithm. We only have these 4 columns about the size, about the feature of the flowers. So after learning, the algorithm will present the relationship among this data. And the result is based on the previous data, not the label. The label only used for display, as I said. So we put the label back after learning and to compare the difference between the botanist and the machine. You can, I don't know whether is that clear for you, but I can tell you that they're not perfect, but they match very well, at least much better than me. So you can see that the unsupervised machine learning is only deal with the data itself, try to figure out the pattern behind the data. The last one is called reinforcement learning. And here you may see that it's a picture of the deep blue. The definition is a computer program interacts with a dynamic environment in which it must perform a certain goal, such as driving a vehicle or playing a game against opponents, like the deep blue from the IBM. And I think most of you already heard about the story about deep blue. So the reinforcement learning is calculate the chance to win each of the move for the chess competition and choose the step that has most chance to win. And it will adjust itself, the strategy, after opponent's move. So for the training, the computer can play the chess game by itself, to simulate every kind of the situation of the move and calculate the chance of to the win. So the computer can improve its self-skill very, very quickly. So that is results the deep blue can win the human beings one day. Long ago, that game I think it happened in 1996, almost 27 years ago, I think, 25 years ago. So that is a story about the 3 categories of the machine learning. Okay, let's talk about the machine learning itself. So technically, there are 2 parts of machine learning. One is data, one is the algorithm. Not that difficult to learn. So the data can be in any kind of the formats, quantitative, qualitative, image, or something else. But eventually, all the data will be converted to binary codes, which can be recognized by the computer. And data can be a table of numbers like we saw in the previous slides, and can be an image, and even can be a very fancy pictures like a cat. But eventually all the image will be converted to pixel and numbers at the end of processing, like the cat. So for an image, the system usually records all the RGB value and location for each point. Let's say it's a pixel. So that will be a huge amount of data for even very single picture. This is data. And for the data, we have some rules. That's kind of the sum of rules. First is the more the better. The more data can reveal the patterns more clearly. It is obviously. And the second is a little bit important because we're learning the data, not remembering the data. As you can see from the image, we try to split the points from the two different categories. One is the blue one, the other one is red one. So we have two ways to split them. One is the black line that you can see is very smooth, but the other one is so complex. So which one do you prefer? Generally speaking, we prefer the black line, the boundary, because that is learning from the data, not remembering from the data. In machine learning, sometimes we call it overfitting. So don't try to do that. That it will harm the results in the future. And also for the data, usually the data will be split into two parts. One is for training data. The other part is called testing data. We usually use the training data to train the machine. That machine to learn the algorithm, the pattern behind the data. It's about, generally we are using 80% of data for training, and then the rest of data used for the testing, to test the outcome, to try whether we can learn something from the data itself. So the training target is not 100% accuracy. Well, the target is to try to keep the accuracy from the training data and testing data to be the same, or maybe to be close enough. So that is a training target. Okay, here we have some algorithms. For the algorithms, you maybe have heard about a bunch of fancy names. As a non-technical user, you only need to know how to use them properly, but not detail. So these fancy names are not that difficult to be understood. Here we have some example called linear classifier, k-nearest neighbors, random forest, and the SVM support vector machine. We can take two of them, for example. It can be understood very easily, don't worry. So for the support vector machine, you can see from the left picture, the purpose is to draw a boundary to separate these two clusters of points. That's all. After that, it will be much easier to predict the points by giving coordinates. Let's say you have another point located somewhere and you try to figure out which cluster it belongs to. So that boundary will help you to make that decision. For the right one, the k-nearest neighborhood. The purpose is to develop a way to determine the green points in the middle, which type it belongs to, a red triangle or blue square. So within a small circle, you may say, it should be a red triangle because the other two within this circle are red triangle. But while with a big circle, it seems to be opposites. So it should be a blue square because there are more blue square presented in that circle. So the key feature is how to define the K. The result will be different as far as you have different value of the K. So that is the KNN algorithm. Okay, congratulations, you already learned two types of machine learning algorithm now. Is that not that difficult, right? Okay, we can deep dive the algorithm a little bit so you can understand the logic behind it, how it works. First, we initiate the model, set up some arguments of the algorithm, something like the maximum loop times, how many times you try to you need the computer to running and get results, or thresholds, or the value like or the value of the K in KNN algorithm. So that is called the system arguments. You need to set it up before learning. Then we feed the data into the model, tells the machine which part is the feature and which part is label. Then the machine will training itself, try to figure out the pattern behind the data. And after some times, until we got the best results and reach the loop limitation. So, and then we evaluate the results. If you're satisfied with the results, then it's all done. Otherwise, you have to adjust the parameters or the arguments and then run it again and again until you're satisfied with the results. Or sometimes you find that you will never have chance to reach the best results as you expected because of the capacity of the computer. So be nice to your laptop. And don't forget, at URI, we have a high performance research computing at URI. So that is why it's over there for the hard duty. Okay, let's pick another interesting algorithm for demonstration. Okay, let's choose SOM, S-O-M. Why I chose it? Because it was my research topic. I like it. Here's definition. SOM, self-organizing maps, is a type of artificial neural network that is trained using unsupervised learning. Remember, this is unsupervised learning, that we only learning from data, not experience, to produce a low-dimensional discrete-sized representation of input space of the training sample. It is a method to do dimensional reduction. It sounds like very awkward, but don't worry, it's totally fine if you don't get it, because me too in the past. But actually, it's not very difficult to understand. Here we have a very interesting example. Let's take a look how it works. Here's a question. How would you categorize these animals? We have the dogs, wolf, eagle, lion, blah, blah, and so many, about 1, 2, 3, 4, 5. Yeah, 12 animals. So how to categorize them? By human beings, we may have our own rules. But how the computers? So first of all, we need to transfer these animals from a picture or from a name to a real data that can be recognized by computer. Say numbers, maybe as I said, only the 1010 can be recognized by the computer. but that is very hard to be understood by us. So let's try to do something first. Let's call it feature extraction. Extract the feature that converts this information from the image from animal to a number that we can know. As you can see from here, we extract 13 features from animals and list them in a table. This is very much better for the computer to understand. So here we only have a feature, but not labels. Remember, we're talking about the unsupervised training that will no labels at all. So the machine will only learn from the data itself. So from data, you can see that we define the size of the animals, the small size or medium size or big size. How many legs do they have? Do they have the hair, hooves? Are they mammals? Are they hunting? Can they run or fly or swim? So that is quite easy to be understand. If yes, we put 1. If no, we put 0. So the data is very straightforward. So what kind of outcome can machine learn from this data? Yeah, after machine learning keep working with some fancy equations and statistics, we got output. Here's the results the machine learning can learn from the data. Don't worry about the labels. The labels is we put a bit back after we learning. So it is clear that the machine sense is quite similar to our human beings. We can take a close look at this image. We can find out the machine puts the dove, oaf, and ducks in one category at the right bottom. And from the left top corner, it categorizes the lion, tiger, horse, cow, wolf, dog, and cats in another category. And it also shows the distance between the different animals. If they are shared short distance, that means they are more close to each other, like the lion, tiger, or horse. So this is the example from unsupervised machine learning. It's quite interesting. And also, I think it can provide another point of view for the data. And it's very useful. But however, the only drawback is this tool is not that easy to be used by scholars that without computer science background. Sometimes you need to figure out how to set up the best arguments to make it run, like the size of this image. We set the size as 5 × 10, so it can display it very properly. And yeah, so sometimes I think the scholars still need help from the computer science to help them to figure out how to use it properly. Okay, that's all. Let's take a look if you have any questions. Oh, so many questions.
Yeah, thank you. Thank you, Leif.
Thank you.
Let's see, we have a few questions in the chat, and the first one is from Marcello. Marcello is saying, Marcello, do you want to ask the question? You can unmute yourself. We're a small group. Are you there? Or I can ask the question. So the question is really about workforce development. He said, I have been working in IT for at least 20 years on software development and started studying machine learning some months ago. How can I find an opportunity to start working on a project as a beginner? It's not easy to find this kind of role. It's more of a career transition, and how can, I mean.
Yeah, I totally understand because I graduated, it's about 20 years ago. So at that time, I don't have the chance to learn machine learning at all. But later on, after I enrolled with a master's degree from the URI, that is my first time to learn the machine learning. So I think it is not very difficult for you if you have some software development background. It's only tell you a kind of the how to say, a different point of view of data, how to process it. In the past, we only know how to let computer to compute the numbers. We know the compute data, but we don't know how to use the number in another way. So machine learning actually is kind of very similar to a statistics. It's try to figure out how to use the data in another way. So in my opinion, it's better to take some very entry level course from URI that will help you a lot. Because after I learning my first class, the machine learning, only one semester, I can get most of sense about how it works. Then later on, it's a kind of advanced class, like deep learning or some very fancy algorithm. But for us, it is very useful to learn the basic concepts and to figure out what is
okay
and how it works. Yeah.
Second one is more from Lynn, more like kind of Lynn is looking for a machine learning person for an NIH grant. She would like to connect with us. So John responded, I responded, like she can connect, send us an email, and we try to find the best way to, yeah, we do have machine learning experts, including you, Lee.
Thank you.
Thanks.
Okay, the next one. Data cleaning from Lynn.
Yeah.
So do you use data cleaning? Do you use machine learning for data cleaning, or is it like outside this cycle?
It's depending on what kind of level of data cleaning. As I said, if the data, we're not supposed to update the data according to our experience. We only, how to say, some kind of data they have problem because of typo. So in that case, we might cleaning the data without machine learning.
Okay.
And also sometimes machine learning can help us to figure out what is wrong with the raw data. So in my opinion, in the past, we received the data from the different state agencies. And after we try to match, we are already talking about how to determine that two persons belong to one. So after that, we identify so many cases that the state agencies, they have some problem with the data entry. The same person but have different name. Some using their nickname, some using their first name. So that is a problem. So that kind of the problem can be recognized by the machine learning. But the rest of them, if a typo like the TYP or TYPO, that also can be recognized by the machine learning sometimes, but also can be identified by human beings sometimes. So it's also depending on which level we are talking about the cleaning.
Once you have the data cleaned, whether you use machine learning for it or you do it yourself, I mean, my most basic question is, how do you choose a model to start with for machine learning and the parameters? How do you choose amongst the models and the parameters to begin?
Yes, depending on what kind of the problem you are going to solve. That is different. Like, first of all, as I said, are you going to clustering the data, or are you going to predict the data?
Okay.
So if you are trying to clean it, I think for the cleaning data, there are so many kind of algorithm, and also my professor told me that the different algorithm will best for the different data sets. So it really depends on what kind of data you're going to process.
So you're thinking in terms of the type of data and the purpose of the prediction, and the purpose of the data. Are you predicting or categorizing?
Yeah.
Okay.
Yeah.
Thank you.
Thank you.
Okay, let's see. A question from Tao. Tao, are you there?
Yep.
Do you want to ask the question directly?
Oh yeah. So like when you're talking about lots of algorithm for do machine learning, so I would like to ask if if I use different type of data, I need to choose specific methods, or like I can choose whatever?
Sorry, it's not very clear here.
Oh, I'm sorry. So
Can
like,
you please loudly, yeah.
Yep. So like when you mentioned about using the different algorithm for machine learning, so I would like to ask is that can I apply like some common algorithm for my data, or I need to look specific what type of my data and fix it with method?
I think so. Yeah. Maybe you can send me an email to discuss about the detailed requirements, so I can think it out in detail.
Yeah, because I read some research about machine learning, and then most of them use SMV or
SMV.
I don't know, like something vector.
Yeah, I know SVM.
Oh yeah, that one.
Yeah, that is fault vector machine. Yeah, I heard about that.
Like some common like Fisher something. But like I'm not sure is my type of data. Like, can I use like any, or I need to look specific?
Yeah, it's hard to say, It's really depending on what kind of data you are working on. And for the support vector machine, as I learned in the past, it tried to set up a boundary between the data sets. So in that case, it will help you to make a decision how to clustering the different data and predicts the points in the future. So that is, I think, that is main goal for the support vector machine. Yeah, so yeah, the way to choose the algorithm is really depending on the data itself and the targets of the data. What are you going to get out from the data? It's not that general, just case by case, I think.
Yep.
So we can talk it in detail after this presentation. Sorry for that.
Thank you. No, you. Thank you so much.
Thank you.
Chris, you're next. Are you still here?
I'm still here. So the question I have is, how do you choose a good training set, and how do you evaluate if you chose a good training set?
So the training sets, the set is, what does set mean? It's a data or algorithm, do you mean? Which do you mean?
No, just from the data, how do you choose a
Data.
good training set from your data?
The data sets, sometimes it's first as much as possible, and then try to figure out what kind of the job you are going to do. I do remember in the future, I got a request from a professor in ocean geography department. and it tried to give me a bunch of data that's try to categorize the different region of the ocean. And the data contains the number of fish, the species of fish, and the plants or the sea level altitudes, so many things, about 100 columns. But actually, only part of them can be used for the training. So I need to sit with him together and try to figure out which column we should left for the training. Some kind of the data that like the fish type. I think that is not very useful for the machine learning, but the number of the fish, that is useful. So that is also a very tricky problem called the feature extraction. So still, sometimes we need to figure out how to use it properly. The first step is to how to extract the data from the data you already have. That maybe calls the training set. Yeah, it sounds fancy, but not very easy to apply. To be honest.
Okay. By the way, Lee, I mean, for training data, do you have much choice because you work mainly with state data?
Yeah, you see, we get data from the state agencies, and they give us so many data. But for the person identification, we only using some PII information, only using the last name, first name, DOB, SSN, and the student ID. Nothing at all. But we still got some information such as the course information, the grading information, even some kind of the like the entry dates, exact dates, exit dates. So probably that will help, but not very useful. So that is kind of filter to try to figure out which information we are going to use for our algorithm. Maybe that still needs to be discussed with the data owner itself to figure out.
Okay. Question from Marcello about machine learning and learning at URI, and Nancy responded. Okay. Nancy, do you want to share it with everyone?
Yeah, sure. Yeah, I wanted to put in a plug for our graduate certificate. It's an online program. It's 5 courses, and the 4th course is machine learning. So we have 3 courses building up to that. One is computing data. It's more of an introduction to data science. And the second one is mathematical methods. And the third one is multivariate statistical learning. And then machine learning. And I think that's a good progression of courses so that, you know, the slide where we had all those little calculations going on, you send the problem into the machine and all the little calculations going on. Well, you get to learn more about what those calculations are in this program. So I think it's a little, you know, it gets you into the background, you know, under the hood of machine learning by taking the other courses in the sequence than if you just took a straight machine learning course without that background. So it's an online certificate. You can complete it in less than 1 year. It's offered during the accelerated calendar. So each course takes 7 weeks. I'd be happy to answer any questions about it.
Yeah. Thank you, Nancy. And I encourage you to check the, just Google URI graduate certificate in data science.
Yeah.
Okay, I think that's it. Thank you, Patricia. Patricia said thanks to Lee and all of us for the introduction. And she follow up with us if she has more questions. Yeah, thank you, Patricia. If you don't have question, I mean, please feel free to unmute yourself and ask question. Otherwise, we'll end the meeting. Any pressing question? 1, 2, 3. Okay. Thank you all. Thank you, Lee.